welcome back to GalaxyPhi Math. Today I'm going to be doing a video on Pythagorean Theorem and Pythagorean Triples and how important it is to memorize some of those triples to help you and give you that edge on standardized tests. So make sure you head on over, not now, watch the video first, but head over to GalaxyPhiMath.com and check out the new subscription. It's only $5 a month, and with it you'll get any Quizlet flashcards that I make to help you memorize. There's some really cool games on Quizlet, and this video is not sponsored. I just love working with Quizlet and it helps so much for any kind of memorization. So be sure to check it out, and please don't forget to hit like and subscribe and hit the little bell so you can be notified anytime I post a new video. Thank you so much, and thanks for watching GalaxyPhi Math. Okay, so today we're going to talk about Pythagorean Theorem, and it states that sides A and B come together to make a right angle, and the line that connects, or I should say line segment that connects the end of A to the end of B is called the hypotenuse, and that's going to be the longest side, and it will be across from the right angle. So Pythagorean theorem states that a squared plus b squared equals c squared. And actually in this drawing, that shouldn't actually have a squared, b squared, and c squared. It should just have a, b, and c. But I'm about to show you how this will actually make sense. So when you have a triangle with and there are Pythagorean triples that are standard sizes that make it easy and quick to come up with whatever the hypotenuse is or one of the legs is, knowing the other two sides. And those you can memorize, and it makes things just so much easier and so much faster when you're taking a test or a standardized test. So we're gonna look at why Pythagorean theorem is true. So you see that first side where I am is the A side, and it's 3 is the distance there. So 3 squared is literally a square. So it's two sides. It's the area of a square. And then we have 4, and 4, and we make a square. Okay, so the area will be one of those sides squared. So we have a squared and b squared. And then we have c squared. And we can actually look and see that the distances are actually 3 on that side, and make sure all of them equal 3. And then that side is 4, and the other side is 5. And so 3 squared plus 4 squared is 5 squared. So that's 9 plus 16 is 25. And that's what it literally means. It's an actual square. You're looking at the area of a square. So memorizing the Pythagorean triples, as I said before, really helps you speed things up on a test. And I urge you to please check out GalaxyPhiMath.com and subscribe. It's only $5 a month, and I will put in special flashcards so that you can remember many of those Pythagorean triples to help you on your tests. Okay, so to figure out those triples, we have a certain equation that we can use, or set of equations that we can use to figure them out, A, B, and C. So for A, you're going to look at m and n, where m and n are integers and m is greater than n. And so for A, that's going to equal m squared minus n squared, and B is going to be 2mn, and C is m squared plus n squared. So you can test those out. I actually plugged this into Excel and came up with a variety of different Pythagorean triples. Now, probably the most common one you'll see is 3, 4, 5. But you can multiply all of those triples by 2 and get 6, 8, 10. And you can also get 12, 16, and 20. And those are just multiples of the 3, 4, 5 triple. But if you use this equation and you put in a few more, you can get a 5, 12, 13. And you can get an 8, 15, 17, and then 7, 24, 25, 9, 40, 41, and 11, 60, 61. And those are some of the most common ones. So for here, I just pop this in Excel, and you see there's my N and M, and I just have them I make sure that M is greater than N. In this case, it's just 1 greater. I move down and that one is 2 greater, and they're just integers. Okay, so I just continue going down with different intervals. So the first interval is 1, and then the second grouping I have 2, on down to an interval of 5, and each one I did 10 total. So, and then you can do multiples of these. So we have A, I plugged in the formula as m squared minus n squared, and then for B it will be 2mn, and then C is m squared plus n squared. And it checks out, so those far right columns are just me checking to make sure that that in fact does equal a squared plus b squared, and that far right column C will be the square root of those summed together. So that is my Excel spreadsheet and how I came up with the Pythagorean triples that I used in my flashcards on GalaxyPhi Math. Okay, so now we have a right triangle. None of these are drawn to scale, just my quick disclaimer, so sorry, but it's just kind of an estimation. So we're gonna have A and B there, and A is gonna be 7, and B is going to be 9, and we're looking for C. So algebraically, how we're going to look at this is to solve for C. And honestly, usually I would do this with variables only, and then plug the numbers in at the end. But this is still pretty straightforward. So 7 squared is 49, 9 squared is 81, and then we're left with C squared. Okay, so 49 plus 81 is 130 and equals C squared, and so we're going to take the square root of 130, and when we do this using the theorem of two squares, we know that's plus or minus. But we're not going to have a negative value for the side of a triangle. It's only going to be a positive value, so because we're talking about distance, so therefore it'll only be positive. Square root of 130 equals C. Okay, so now we have the triangle flipped and the hypotenuse is on the other side, and we know what it is. And we can write it as 30 squared plus b squared equals 50 squared. And we're looking for b here. But stop for a second and just look at 30 and 50. Is there anything that might look similar to or could be a multiple of? And of course we know that it could be a multiple of the 3, 4, 5 triangle, and that b could in fact be 40 because 30 and 50 are multiple of 3 and 5. And you would be right to assume that. So if you have a multiple of any of the Pythagorean triples, you can quickly find the answer. We can also do it the slow, old-fashioned way using big numbers, and it's going to take a little bit longer, but it's not too bad. So you would end up with 2,500 minus 900 equals b squared, and then You know that 2500 minus 900 is 1600. And once you take the square root of 1600, you end up with b, which will be 40. Alright, so here's another example. And we're going to say that one of the legs, or sides, is the square root of 23. And then we don't know the other side, which we'll call b. And our hypotenuse is 12. Okay, so I don't see any easy Pythagorean triple here since we have the square root of 23 in there, but let's just plug it in our old-fashioned a squared plus b squared equals c squared and see what we get. So when we solve for b, we're going to have b squared equals c squared minus a squared. And this is just our simple algebra and pulling that a squared over. And then we're going to take the square root of both sides to get b equals the square root of c squared minus a squared. And when we plug in our c, which is the hypotenuse, 12 squared, minus a square root of 23 squared, we end up with b equals the square root of 144 minus 23. So then we have b equals the square root of 121. And if we've gone over our flashcards for the square roots, we know that the square root of 121 is 11. So check those flashcards out, definitely on GalaxyPhiMath.com. You can subscribe for only $5 a month and get as many flashcards as I can possibly make for you. So please check that out. Okay, now we're going to look at another one and see if maybe we recognize a Pythagorean triple on this one. So just as with the 3, 4, 5 triangle, you can have multiples of some of the other Pythagorean triples, and those will count as well. So we see a similar triangle. Again, these are not drawn to scale. I apologize for my artwork. But this is actually a 5, 12, 13 triangle, and you can recognize the top triangle as a multiple of that. So we'll end up with 10, 24, 26 as our triple, and that was quickly solved, just as it would be on those standardized tests where time is so valuable. Okay, and so if we do it the long way, we have a squared plus b squared equals c squared, and b equals the square root of c squared minus a squared. And when we plug everything in, we end up with b equals the square root of 26 squared minus 10 squared. And we're beginning to realize that, okay, well, we know the answer is 24, and we don't want to have to square 26. Although 10 squared is only 100, so it wouldn't be that bad, but obviously it's quicker just to know the Pythagorean triple. So you're starting to see my point, I imagine. Now this one, that is 11 on one side, b on the other side, and 61 is the hypotenuse. So hopefully you are taking my advice and starting to memorize some of these triples. So I see that and I think, well, I know that answer is 60. Simple as that, super fast, super easy, and we're done with the problem because I put in the time to memorize those Pythagorean triples. So I hope you do the same. I hope this helped and that you enjoyed the video. Please don't forget to like and subscribe, and thank you for watching GalaxyPhi Math.